A protože to nedělá deming.
Můžu to zahájit, protože už máme stejně minutu pryč.
Jo, už asi jo.
OK. Ještě to nám si zapněte, jo.
Tak můžeš přes můj.
Okay, welcome to the talk about global revolution in machine learning. And let me introduce you Fridolín Pokorný, who is a software engineer in Red Hat Czech. He started as a platform engineer, then he moved to Golang packaging automation and Kubernetes, and now he is part of the machine learning team, and he will tell you some more technical details than Daniel Rick in previous presentation. So it's your floor.
Thank you. Okay, can you hear me? Okay, so first, please raise your hand if you have ever interacted with machine learning or AI, ever. Okay, I see almost everyone, and I'm quite sure that every one of you interacted with machine learning and AI somehow. If I talk about AI and machine learning with my grandma, she will probably imagine something like this. This is AI. Like, it's something that speaks to me and I don't understand it. It can drive some spaceships. It can even repair it during some spaceship battles and so on. Well, actually, this is not AI, at least not today. So what is artificial intelligence? So by artificial intelligence, we mean something like what tries to mimic human behavior. There's a very nice test that was created by Alan Turing in his Computing Machinery and Intelligence paper. And this test basically described that you have a machine and then you have a person, you put them into two separate rooms, and you ask questions. You don't directly interact because you could, for example, ask questions that you could see that based on voice, it's a machine, but based on output of these two creatures, you can check whether it's a creature, like a human being, or if it is a machine. So by this test, you can easily test whether it's artificial intelligence, like the machine. Well, this test is not that common, or it's not used, and a lot of people disagree with it. You can see artificial intelligence, like, for example, programming a prologue. In prologue, where you state some bases, and basically you ask prologue interpret, okay, is John father of Jake? And based on the knowledge base that you provided to prologue, like family tree, prologue can answer this question. AI is, as you can see, very broad thing. So if we focus more on things that go inside AI, we can also focus on machine learning, and that's a particular area in AI. And what machine learning does, it basically tries to mimic human behavior, but using machines that are not explicitly programmed. So you can imagine you have a data set, like average price of house in Brno, and in past 10 years, and you pass this data set to some algorithm, and this algorithm can automatically tell you, okay, in 1 year, the price of a house will be, for example, some price. This example is simplified. You have to consider also some features like what is the actual size of house, where is it located, and so on. So you have to also consider these things. Okay. Another part of machine learning is deep learning, and this is probably the most exciting, and this is the thing you see in headings like AI did something or accomplished something. And deep learning is also something that gives you the biggest revenue, at least today. So what is deep learning? By deep learning, we mean we are trying to model human brain. And if we think of human brain, like how it works, our brain works in a multiple level of abstractions. So if you see someone and it's Jake, your friend, you see that he's made of eyes, he's made of eyebrows, ears, nose, and your brain somehow creates the wall figure of Jake, and based on your previous observations, based on of your learnings, you know that this is Jake. Okay, so let's try to have a look at the building blocks of our brain. So the core concept or the main building block of our brain is a neuron. It consists of body, dendrites, and axon. So if you see someone, the signal from for example, eye goes through nerves, through dendrites to cell body, and here it can activate and activates neuron and activates based on. Neuron activates based on previous learnings. If the amount of activation is given by these learnings, and then the signal goes through axon to other parts of your brain, to other neurons, and basically the signal goes on and on in your body. The creating neurons, like creating them using machines, it's not something novel. Even in 1943, two clever guys, McCulloch and Pitts, tried to create something they call thresholded logic unit. And it basically multiplied input with some weights, and they created some thresholding function that was hard-coded, and it could produce logical operations like OR and NOT. So this was like first artificial neuron. The downside is that there is no actual learning, so you have to basically put all values in it, and it somehow worked. Subsequently, Rosenblatt, founder, who is considered to be founder of neurocomputing, in 1957 created basically neuron or perceptron that is used nowadays in deep learnings. And the downside for this was that mean scheme showed that it's impossible to basically separate XOR function using a simple neuron. So that was considered like the end of neural networks. However, research continued, and in 1986, Rumelhart created a backpropagation algorithm that is famous even today, and it's used in deep learning neural networks. And it basically showed that neural networks can learn very, very complex functions. Jan LeCun subsequently created a deep neural network that was capable to recognize handwritten digits. It was some research, and the main aim was to basically categorize letters on post offices. Now we have different types of neural network, and there's large research going on. So how does it work, like in details? You have some neurons. You put these neurons in one layer, and then you put more layers on top of other layer, and you feed some input. And there are two main parts, like training. You first need to train your model, and then there's actual prediction or interference. Very important to state here is that the more layers you have, the more complex functions you can learn. This is example taken from playgroundtensorflow.org, and here you can see that very first neurons learn very basic functions, and then subsequently these neurons learn more complex functions, and at the end they can create some boundaries around dots that are very complex, and there's no clear way how to do it like mathematically properly without neural networks. If we apply this to, for example, neural networks that are learned to recognize some parts on images, some humans or dogs, the very first layer could output something like this. These images are created by creating input that activates neurons most. So this could be, for example, first layer, and subsequently other layers can create such images where you can see features that these neural networks have learned based on your input. So why there is such hype nowadays in machine learning and AI? There are two main things that drive this hype. First is we have a lot of computational power, especially GPUs that are suitable because large neural networks are easily parallelized, or there can be specialized units like TPUs, tensor processing units that are specialized to do neural networks computations. Also, important thing is data aggregation. Now we have a lot of data that we can use to learn neural networks or classical machine learning algorithms, so we can come up with very nice results. The more data, the better, and data are very important. Okay, so this is very exciting, and now everyone of us wants to do machine learning, so how we can start? Basically, you can do whatever you want to do with machine learning, just experiment. Generally speaking, it's possible to do whatever a human being can do. It's because you need input data, and basically this input data has to come from somebody, or it has to be labeled. And you can do anything that is doable for a human being or human expert in that particular area under 1 second. So if you want to do, for example, recognition of breast cancers, you can do that if you have properly labeled input data. So data, it's very important to have data. It's almost everything about data. If you check research papers, you can see that to train neural networks for image classification or something like that, you need to have thousands or millions of labeled data. For audio samples, you have to have like 15 to 100,000 hours of labeled data, so that's very expensive. It's also applicable to have 80 to 20 rule. You spend most of your time doing data preparation, feature extraction, how you can basically, what you can see in your data, and 20% you can spend on actual model design and fine-tuning your model. Okay, so now we have a model, we deploy it, we designed it, but that's not the end. Recommendation systems or machine learning systems, they need to retrain model so they reflect users' input. So when you deploy a model, you want to attract users. These users produce other data, and these data are then subsequently fed to machine learning models, and again, to get better results or to adapt in time. So it's very important to have data. I did some enumeration, like very nice things that come up in last year. I think worst stage is pneumonia detection, XNet. It's a deep neural network. Just to have a notion how many layers we can have, it's 121 layered convolution network. Convolution networks are designed to be more like our visual context. And as input for training, there were used more than 100,000 X-ray images, and that were labeled by experts. This machine learning model can outperform a team of experts because it can learn very, very good. Here are some other world-class achievements. The most of the time I spent speaking about supervised learning, but for example, AlphaGo, the model that was created in DeepMind and was able to play chess. It's very nice to showcase how it works in case of reinforcement learning, where you state some rules, so you don't need to have explicitly data, and by these rules you basically punish your model or you give it rewards based on things it did previously. So if you want to take a look at machine learning or AI, take a look at Andrew's NG talk, like artificial intelligence is the new electricity. He states some very nice ideas here. He's also some leading researcher in the AI era today considered. And also take a look at Coursera machine learning courses. And also, for example, Kaggle competitions where you can find nice input data and you can also compete with others. So thank you. In case you have questions. Mm-hmm. AI in general, it's very large industry. Okay, so basically the question was, why did I speak about deep learning and these kind of things if we have also other parts? The main idea is that deep learning basically drives this research, and it's also the field that gives us the biggest revenue. And there are also other fields, like especially in machine learning, where you can create mathematical models that are very complicated. And I don't think I would put it into 15-minute presentation. So, any other question? Yeah.
Someone already put Bugzilla to
Oh, that would be nice. So the question was whether someone put Bugzilla. And I think there are possibilities. Yeah, I think so. I saw a talk about basically finding bugs in the source code based on commit messages. It's talk, and they achieved 70% accuracy, so that was quite good. Any other question? Natural language processing. So the question was whether natural language processing is a good case for deep learning, or yes. The reason why I showed basically images, it's because it's very easy to show what these neural networks learn. You can see what is inside different layers. And you can also apply, for example, sequence-to-sequence models that can read sentence in one language and translate it into another. But that's not that straightforward as for example, images and showing what neurons can learn on different layers. Any other question? Okay, if not, and you have some questions, feel free to reach out to me. So thank you.